Hi guys, it's Chemistry Fun here, and today we'll be looking at elimination reactions or dehydration of alcohols. Okay, before we can go through the mechanism of elimination, we have to consider two rules because not all alcohols can undergo elimination reactions. Rule number one is that there must be a hydrogen bonded to a carbon atom adjacent to a OH group. So for example, if we have ethanol here, we can see that this follows the rule as there's a hydrogen bonded to the carbon which is adjacent to the OH group. Rule number two is that if the OH group is bonded to a middle of a chain, a carbon chain, it could create two products if the alcohol is unsymmetrical, because this hydrogen can bond to this carbon-carbon bond, or this lone pairs from these can attach from the other, so vice versa. Now, okay, so we're gonna go through elimination mechanism of a simple alcohol. So we'll start with ethanol. Ethanol is this in the structural formula, and it's displayed formula. And the first step is that the lone pair of electrons on the oxygen, on the OH group, is attracted to a hydrogen ion. This creates this makes the hydrogen ion attached to the oxygen of the OH group, but also it creates a positive charge there too. This therefore, the pair of electrons from the carbon and oxygen pair moves towards the positive charge, which gives us water and a carbocation. This carbocation with a positive charge on one of the carbons. And then the pair of electrons from this carbon-hydrogen pair goes towards the carbon-carbon pair of electrons to create a double bond. This therefore makes ethene in this example, plus a hydrogen ion. So technically, the overall reaction would be this alcohol turns into water and this ethene, because these H plus ions cancel out. Now if we do a harder example, for example propanol, with propanol, we'll do the first step. So the lone pair gets attracted to the H plus, which in turn creates a bond between the hydrogen ion and the oxygen, plus a positive charge. Plus a positive charge, and the pair of electrons between the carbon and the oxygen gets attracted to the positive charge, creating water. With two lone pairs of electrons, and a carbocation, which in this case would be this carbocation, and then the pair of electrons from the CH bond adjacent to it, which is this one, gets attracted to the single carbon-carbon bond to create a double carbon-carbon bond, which therefore would create a alkene. I can't draw onto here, but yeah, this alkene, which is propan-1ene, or prop-1ene, prop-1ene. Now, for example, if we consider rule 2, so let me remind you, if the OH group is attached to the middle of a carbon chain, it could create two different products depending on the alcohol. So if the alcohol is unsymmetrical, it would create two different products. But if we do a symmetrical product, such as propan-2-ol, which is this, and the lone pair gets attracted to a hydrogen ion, and that hydrogen gets bonded to the OH. And then it also creates a positive charge, and then this pair of electrons from the CH, because that from rule 1 it has to be adjacent to the carbon, so it has to be this one because that's the only one. That gets attracted to the positive charge and leaves the alcohol to make water. And a carbocation, which would be this one. And then the hydrogen from one of the sides. So, for example, if this was an unsymmetrical alcohol, where one half is different to the other half, that would create a different product to the other one. So if we do it from this side, this goes to that bond, that would create this alkene. But if that hydrogen goes to that bond, it would create this alkene. But fortunately, since we chose propanol at the start, propan-2-ol, they're the same alkene. But say if we used methyl butanol at the start, that would create two different products, and that would give you a mixture of alkenes. Thanks for watching. Please like and subscribe. Bye.